Magandang araw uli at welcome back sa ating channel. Ang topic natin sa video na ito ay ang tungkol sa calculation ng sub-transient currents using per unit method. Pero bago tayo magsimula ay gusto ko munang pasalamatan yung mga subscribers natin na patuloy na sumusuporta sa ating channel. At iniimbitahan ko na rin yung mga hindi pa po nakasubscribe na mag-subscribe na po sa ating channel. Maraming salamat po at umpisahan na natin. So dito sa ating sample problem, sa diagram makikita natin meron tayong isang transformer na 100 MVA with a voltage of 13.2 kV to 138 kV and a transient reactance of 0.1 per unit. And then it is being fed by 3 generators connected in parallel to a common bus. So yung dalawang generators natin are identical, yung generator 1 at generator 2, which is both 25 MVA, 13.2 kV, and with the sub-transient reactance of 0.14 per unit. And then yung atin namang generator 3 is 50 MVA, 13.2 kV, and with the sub-transient reactance of 0.14 per unit. So ang ating question is, sabi is, if the voltage on the high voltage side of the transformer is adjusted to 132 kV, the transformer is unloaded and no current is flowing between the alternators, calculate the sub-transient currents in each of the alternators. So ang i-calculate natin is yung mga sub-transient current dito sa mga alternators na to. Okay? Sa calculation ng mga short circuit using per unit method, ang una natin ginagawa is nagde-define tayo ng base ng two base quantities, which are yung base power, which is expressed in MVA or kVA, and then yung base voltage, which is expressed in kV. So dun sa previous video ko tungkol sa per unit system in power system analysis, is dun ko pinaliwanag yung mga tungkol sa mga mga per unit values rather, at yung mga formula na ginagamit natin sa per unit calculations. So kung hindi nyo pa po napapanood yung video na yun, ilalagay ko dito sa description sa baba yung link para mapanood ninyo at ma-review ninyo. Kasi yung mga formula na gagamitin natin sa mga calculations dito ay naipaliwanag ko dun sa video na yun. Kung medyo hindi kayo familiar sa mga formula, mas magandang ma-review nyo muna yung video na yun para hindi kayo malito sa mga calculations na gagamitin natin dito. Okay? So ang rule lang naman natin sa pag-a-assign ng mga base power at base voltage is as much as possible ma-minimize natin yung conversion from one base to another. Ang kadalasan ginagamit is 10 MVA sa base power or 100 MVA. And then sa voltage naman is kung ano yung common voltage dun sa bus. Pero hindi laging ganon. So iisipin lang natin ano ba yung base value na pwede natin gamitin na ma-minimize natin yung conversion ng mga base ng mga values from one base to another. Okay? So for this example, ang gagamitin nating base power is S base is equal to, let's say, 50 MVA. And then ang S voltage base is equal to 13.2 kV. So gamitin natin itong parameters or itong mga values para sa generator 3 as base values. Okay? So ngayon, dahil nakakuha na tayo ng ating base values, nakapag-assign na tayo ng ating mga base power at base voltage, ang susunod natin gagawin is i-convert natin itong mga reactances natin sa bawat component to that common base, which is yung base na inassign natin. Okay? So ang ating magiging X per unit sub-transient reactance mu is equal to sub-transient reactance old times S base new divided by S base old times yung voltage base old divided by voltage base mu squared. So itong formula na to is na-discuss ko na to doon sa previous video. Reviewin nyo na lang. So ang mangyayari dyan is isa-substitute natin. So kung para dito sa generator 1 and 2, let's say x1 sub-transient 1 mu is equal to yung old natin is yung given. So pag sinabing old, ayun din yung given. Okay? So 0.14 times yung S base new is 50 divided by S base old, which is yung 25, and then kV old or yung base voltage old, which is 13.2 divided by S base old new. S base new is 13.2 din. So dahil pareho naman yung ating old tsaka new base, so wala nang effect yung ating voltage dyan. So pwede natin i-cancel out yan, magiging 1 na yan. Okay? So magiging x1 prime, double prime or sub-transient new is equal to x2 sub-transient new is equal to, so pagka kinalculate natin yan, ang lalabas dyan ay 0.28 per unit. 0.28 per unit. Okay? So, meron na tayong reactance para sa ating generator 1 at generator 2 based on the new base. Okay? So, ngayon, para dito naman sa ating generator 3, since ang ginamit nating base values is yung para sa generator 3, so yung reactance niyan 3 is equal dun sa mismong reactance niya, yung old, which is equal to 0.14 per unit. Okay? Ngayon, pagdating naman sa ating transformer, meron tayong, let's say, X transient reactance X ng transformer mu is equal to, yung old is equal to 0.1 times yung ating S base, which is 50, divided by S old or yung given, which is 100, and then times yung voltage base old, which is 13.2 sa low side, 13.2, and which is also equal to yung ating base voltage, 13.2. So same thing kanina, magka-cancel out lang din yan. So ang ating magiging new sa transient reactance sa transformer is equal to 0.05 per unit. Okay, so ayan yung ating magiging bagong reactance ng transformer base dun sa ating bagong mga base values. Okay, so ngayon na i-convert na natin yung ating mga per unit reactances based on the new base values. Ang susunod naman natin gagawin ay kukunin natin yung mga internal voltages dun sa alternator. Pero bago natin magawa yun is kailangan muna nating kunin yung corresponding low voltage, yung corresponding voltage rather dun sa low voltage side ng ating transformer. Kasi ang sabi sa problem is yung high side daw ng ating transformer is in-adjust to 132 kV. Pero ang rating niya is 138. So by ratio and proportion, makukuha natin yung corresponding value or voltage sa low side ng ating transformer. So pag in-apply natin yan, dahil yung ating low side ng transformer sa yung original rating is 13.2 and then yung high side is 138. So ito yung ating transformer ratio, which is yung A, di ba? VP primary over VS. So equal yan sa voltage sa low side divided by yung adjusted na voltage sa high side, which is 132 kV. So therefore, yung ating voltage sa low side na makukuha dyan is equal to 13.2 times 132 divided by 138, or equal to, pag kinalculate natin yan, ang lalabas dyan is 12.626 kV. Okay? So yan yung ating bagong actual voltage doon sa low side ng ating transformer. Pero dahil ang ating per unit voltage is equal to actual divided by base. Okay? So ang magiging actual natin is ito sa low side, 12.626 divided by yung ating base is 13.2 rather, 13.2. So therefore, ang ating per unit voltage dun sa low side ng transformer is equal to 0.957 per unit. Okay? So ayan yung voltage dun sa low side dito sa part na to. Which is ayan din yung voltage dito sa bus kung saan nakakonect yung mga generators natin in parallel. So therefore, masasabi natin na yung internal voltages ng tatlong alternators is equal to 0.957 per unit. Ayan din yun. So yung ating E sa alternator 1 is equal to E sa alternator 2, which is equal din sa E sa alternator 3, which is equal to 0.957 per unit. Kasi nakaparallel lang naman yung mga yan sa ating bus. Okay? So, ang susunod naman natin gagawin is i-drawing natin yung ating reactance diagram at i-calculate natin yung sub-transient current at the point of fault. So, ito na yung ating reactance diagram. So, ito na yung value ng ating converted per unit reactance sa J.28, J.28, J.14, and then J.05 naman sa ating transformer. So, ang ating sub-transient current, short circuit current sa point of fault is equal to yung ating source voltage divided by yung total reactance. So yung total reactance dito is yung equivalent reactance sa combination nitong tatlong parallel and then series dito sa 0.05. Okay? So calculate muna natin yung ating equivalent reactance. So ang ating equivalent reactance is equal to 1 over 1 divided by J 0.28 plus 1 divided by J 0.28 plus 1 divided by J 0.14 plus J 0.05. Okay? So equivalent reactance is equal to J 0.12 per unit. Okay? And then yung ating sub-transient current, fault current at the point of fault is equal to supply or source voltage, which is yung sa alternator, divided by yung ating equivalent reactance up to the point of fault, which is yung 0.12. So substitute natin yan, 0.957 divided by J 0.12. Okay? So it's equal to 0.957 C sub 0 degrees divided by 0.12 C sub 90 degrees. Okay? So equal to, pag kinalculate natin yan, lalabas dyan is 7.98 C of negative 90 degrees. So therefore, yung ating sub-transient current for fault current sa point of fault is equal to negative J 7.98 per unit. Okay? And then pag nakuha na natin yung ating sub-transient current at the point of fault, kunin naman natin yung ating voltage sa per unit voltage sa low side ng ating transformer, yung sub-transient voltage, which is equal to, sa pag ginamit natin yung formula na V is equal to I times X. So therefore voltage is equal to sub-transient current times yung reactance ng ating transformer. Okay, so yung ating sub-transient current is negative 7.98, negative J 7.98, and then yung ating transformer is J 0.05. So therefore yung ating V is equal to 7.98 cis of negative 90 times 0.05 cis of 90 degrees. Okay, so magka-cancel out lang yung ating angle. Magiging voltage natin is equal to 0.399 per unit. Okay, so ngayon ang susunod naman natin i-calculate is yung sub-transient current to individual alternators. So, ang ating formula dyan is sub-transient current sa individual alternator is equal to yung voltage drop sa alternator divided by yung ating reactance do sa alternator. Okay? Okay, so yung ating voltage drop is equal to yung sa ating source voltage at yung minus naman yung voltage sa terminal ng ating transformer. So, which is ito is equal to sa source voltage, which is 0.957 minus 0.399 per unit. Okay? And then meron naman tayong reactance ng alternator 1 or alternator 2 or alternator 3. Okay? So pag substitute natin yung mga values na yan, so ang ating magiging sub-transient current sa alternator 1 is equal to sub-transient current din sa ating alternator 2 dahil na identical nga yung ating dalawang alternators na yan, which is equal to 0.957 minus 0.339 or 399, sorry, that's 399, divided by yung reactance natin sa alternator 1 or 2, which is J 0.28. Okay, so malalabas dyan is 0.558 divided by J 0.28 or equal yan sa ating 0.558 cis of 0 divided by 28 0.28 cis of 90 degrees. Okay, so equal to 1.99 cis of negative 90 degrees. Or pag kinonvert natin yan sa ating rectangular form, sub-transient current sa alternator 1 is equal to sub-transient current sa ating alternator 2 is equal to negative J 1.99. So negative J 1.99 per unit. Okay, yan yung para sa alternator 1 and 2. Pagdating naman sa ating alternator 3, so sub-transient current sa ating alternator 3 is equal to yung voltage drop pa rin, which is 0.957 minus 0.399 divided by yung converted sub-transient reactance sa alternator 3, which is J 0.14. Okay, So equal to 0.558 ulit divided by J 0.14, which is equal to 0.558 C sub 0 divided by J, or 0.14 C of 90 degrees. So therefore, yung ating sub-transient current sa alternator 3 is equal to 3.99 C of negative 90. Or, pagka kinonvert natin yung sa rectangular, sub-transient current sa alternator 3 is equal to negative J 3.99 per unit. Okay? So ngayon, meron na tayong mga per unit current sa ating alternators 1, alternator 2, and alternator 3. So pag ginamit naman natin yung formula na value per unit is equal to actual divided by base. Okay? So itong hinahanap natin yung actual short circuit current at sub-transient current sa ating mga alternator. So meron na tayong per unit, na-calculate na natin yan, ito tsaka ito. Kunin muna natin yung base. Okay? So dahil nag-assign tayo ng base power, which is yung 50 MVA, at yung ating base voltage is equal to, yun natin ang base yan, sa 13.2 kV. So makukuha natin yung ating base current. So ang ating base current is equal to SB base divided by voltage base, di ba? So pag nakuha natin yung dahil 3 phase yan, so square root of 3 tayo. Dahil 3 phase yung ating base power, square root of 3. So substitute natin yung ating value. So ating base power is 50 kVA, 50,000 kVA, which is equal to 50 MVA divided by square root of 3, and then 13.2 kV. 2 kV. So ang lalabas dyan is 2186.93 amperes. Yan yung ating base current. So substitute naman natin ito doon. So ang ating actual current sa sub-transient current sa alternator 1 is equal to sub-transient current sa ating alternator 2, which is equal to yung ating per unit, which is negative J 1.99 times yung ating base, which is 2186.93 amperes. Okay? So, lalabas dyan is I sub-transient sa alternator 1 is equal to I sub-transient sa ating alternator 2 is equal to 1.99 Cs of negative 90, and then times 2186.93 Cs of 0. So, lalabas dyan is 4,351.99 Cs of negative 90 degrees amperes. So, yan yung ating sub-transient sa alternator 1 is equal to sub-transient current din sa ating alternator 2. Okay? So, amperes. And then, para naman sa ating alternator 3, so, sub-transient current sa ating alternator 3 is equal to, ang ating per unit sa alternator 3 is negative J 3.99 times yung ating base, which is 2186.93 amperes is equal to 3.99 Cs of negative 90 degrees times 2186.93 Cs of 0 degrees. Okay? So, is equal to 8,725 sees of negative 90 degrees. So, ayan yung ating sub-transient current sa alternator 3. Okay? Hanggang dito na lang po ang ating video at sana'y may natutunan na naman kayo. Maraming salamat po at God bless sa inyong lahat.